Welcome to section 5.4 on factoring trinomials. So considering the following multiplication by foiling, we have x plus 3 times x plus 4 is equal to x squared plus 7x plus 12, right? And we could see from here that if we add the 3 and the 4, we'll get our middle number 7. And if we multiply 4 and 3, we get our last number, which is 12. So what does that mean? That means a strategy for factoring x squared plus bx plus c. We write x as the first term in both factors. List out the factor pairs of c, determining which one adds to make b, and then check your answer by foiling the resulting binomials. And if you cannot find factors of c that add to b, then the trinomial is considered prime over the set of integers. So, for example, we have x squared plus x minus 2. So there's only two factors of 2, 2 and 1. And to get the positive x, positive 1x, and the negative 2, we need the 1 here to be negative and the 2 to be positive. So x plus 2 times x minus 1. For x squared plus 9x plus 14. So this one has one additional factor pair. We have 1 and 14 and 2 and 7. The only one that makes 9, though, is 2 and 7. And since 9 is positive and so is 14, both of these are additions. So x plus 2 times x plus 7. I have, is this trinomial here factorable? The only factors of 5 are 5 and 1, and they don't somehow combine to make a 1. So this would be a no. This would be that prime over the set of integers. And if that were to happen where we can't exactly factor immediately, we can try to factor out a greatest common factor. So this is where a polynomial is factored completely when it's written as a product of prime polynomials. So for example, on the example I have here on the screen, 2x squared plus 10x plus 12, all three of those share a 2. So we could factor out a 2 and be left with x squared plus 5x plus 6 to find out what times 2 made 10 and what times 2 made 12. So now, for the x squared plus 5x plus 6, that does factor nicely. The only way that we could get a 5x and a positive 6 would be if we use the factors of 3 and 2, and both of them being positive. So 2 times x plus 3 times x plus 2. Now we want to factor these trinomials, 3x cubed minus 21x squared minus 32x. So this does share stuff in common. It shows both a 3 and an x. So 3x times 3x times just x squared makes 3x cubed minus 3x times 7x makes 21x squared minus 3x times 44 makes 132x, so minus 44. Now 44 does have a lot of factors, but thankfully, the only one that works is if we used 11 and 4. And to get a negative 7 and a negative 44, we have a negative 11 and a positive 4. So 3x times x minus 11 times x plus 4. Is that complete factorization? For 4x cubed minus 40x squared plus 84x, we could factor out a 4x. And we would be left with an x squared minus 10x plus 21. And that factors to be 4x times, the only factors are 21, other than 1 and 21, are 7 and 3. And if they were both negative, we get the negative 10 and the positive 21. So 4x times x minus 7 times x minus 3. That's part 1 of section 5.4. Do be on the lookout for part 2. Thank you.